So this is our first template of notes about continuity. If you haven't taken a look at that, please do so. But what we're going to concentrate on in this video is a few examples dealing with piecewise functions that are not graphed for us. We actually have to just look analytically at these functions. So this says to determine whether the function is continuous at x equals 2. Well, in order to do that, we need to make sure that the limit exists. If we're going to make sure that the limit exists, then we need to take the left-hand limit and take the right-hand limit and make sure that they equal the same thing. Well, in this case, the left-hand limit would be 2 squared, or 4, and the right-hand limit would be 6 minus 2, which is 4. Notice that the left-hand limit and the right-hand limit are equal, so therefore the limit exists. Alright, and in a previous video, I drew a smiley face every time we met a condition to continuity. So there we go. The limit exists. So now what we have to do is say that we're going to check f of 2, and if we substitute in 2, then that gives me 6 minus 2, or 4. So f of 2 equals the limit value as x approaches 2 of f of x, because that limit value was 4. Those are both 4s. So f of x, let's say therefore, f of x is continuous. And I probably should have drawn another smiley face here, because that means that we've met another condition. Okay, so maybe I'll switch pen colors just to give you guys a break from that black. Okay, so determine whether the function is continuous on this one. Well, in order to determine whether something is continuous, I need to make sure that the limit exists. So the limit from the left has to equal the limit from the right. Well, from the left, it looks like I'd get 2 squared, or 4. The limit from the right of x equals 2, that would give me 6 minus 2, which is still 4. So we're pretty happy about that. The limit exists. All right? The issue arises when we go to check the next piece. When we go to check the next piece, we're getting f of 2. We go to substitute in 2, and it's not defined. So therefore, f of 2 is not equal to the limit value as x approaches 2 of the function. Sorry for ending up on the side of my page there. So therefore, f of x is not continuous. Still on the side of the page, so sorry about that. So we're going to do like a little frowny face here, because this is where the definition of continuity is not met right there. Okay. On the next one, the next couple of problems, it doesn't ask us if it's continuous. It says find a value of c which makes this function continuous. Well, in this case, I'm going to start this thing off the same way. I need the limit from the left-hand side of 2 to equal the limit from the right-hand side. Well, from the left-hand side, I'm getting 8 plus 6 minus 5, 14 minus 5, or 9. Now the limit from the right-hand side of 2, I'd have to plug in 2 for x, so I get 2c plus 3. Now we know that those are supposed to be the same in order for the limit to exist. Well, that's what we're going to do then. We're going to make sure that they are the same. 2c plus 3 equals 9. We'll subtract 3 to get 2c equals 6, and divide by 2 to get c equals 3. I assume that that is probably going to be the answer. Okay? However, let's double check and make sure that not only the limit exists, but the function is going to be continuous. So we did make sure that the limit exists, okay, when we substitute in 3. But now we need to make sure that the function value at 2 is equal to the limit value. Well, the function value at 2, we would just substitute in up at the top, and that would still be 9. So the limit as x approaches 2 of f of x equals f of 2. So we are happy about that. So therefore, we have just made this thing continuous with c equals 3. So c equals 3 makes f of x continuous. Okay. And the last example. The last example I'll do in red. You know why? Because I've messed up on this one pretty recently. So let's do this. Okay, so find the value of c which makes the function continuous. Okay. So what would we typically do? Well, we would typically say the limit as x approaches 2 from the left of this function, and we would go right in and substitute it in. Well, there is no x less than 2, right? It says x is not equal to 2, but really if you did x is less than 2, or x is not equal to 2, that's the same as saying x is less than 2 or x is greater than 2, right? Well, if you went to do that and you substitute in 2, I wonder what you would get. Well, that's 4 plus 6 minus 10 over 2 minus 2. And this gives us 0 over 0, which is an indeterminate form. Okay, so if you get an indeterminate form in a problem, you typically have to factor or rationalize or simplify a complex fraction, or maybe even use a trig identity. In this problem, it just looks like we're going to be factoring. So what we're going to do is factor the numerator into the numerator. So we're going to take the limit as x approaches 2 from the left, and instead of writing f of x, I'm just going to write that top part down, and maybe I'll go ahead and factor it. What are the factors of 10? 1 and 10, 2 and 5. So which pair of those factors will add up to 3? I think that'd be plus 5 and a minus 2. So x plus 5, x minus 2, and now I have an x minus 2 in the denominator. Thankfully, I can cancel out. Once I've canceled out, I can drop the 2 in, and that's going to actually give me an answer of 7. Now, just imagine doing the same thing for the limit as x approaches 2 from the right. Well, the limit as x approaches 2 from the right, you'd still have the same factors. That wouldn't change. And the x minus 2's would still cancel. And I could still then drop in the 2 right here by direct substitution. So I'm getting 7. So the limit exists, and we're happy about that first point. Now we just have to ensure that the function value at 2 equals the limit. Well, the function value at 2, the way it's written, is the function value of 2 actually equals c. But we want it to equal 7, so we're just going to say that if c equals 7, that makes this thing continuous. Okay? Because that function value equals the limit value as x approaches 2 of f of x. Alright, so I'll just write, so c equals 7 makes f of x continuous. And that's all she wrote for this video. I've done my best to try and help you guys learn about continuity in various situations, but in this case it's dealing with mostly piecewise functions. So take that, enjoy it, and try to use that to solve some of your practice exercises. Take care.